All right, let's get right into it. For years, there's been this set of, well, simple-looking visual puzzles that have been a kind of final boss for artificial intelligence. Seriously, they're easy enough for a kid to solve, but they have completely stumped even the most powerful AI systems out there. But in 2024, one team, they finally cracked the code. So let's break down exactly how they did it.
So, take a look at this. You see a couple of examples of an input grid turning into an output grid. Your task is to just figure out the rule and apply it to a new one. Seems pretty simple, right? You probably spotted the pattern in, a few seconds? So why has this been a total brick wall for AI? Well, this isn't just some fun brain teaser. It's a real benchmark for what we think of as true general intelligence.
And this set of puzzles has a name, the Abstraction and Reasoning Corpus, or ARC for short. Its whole reason for being is to test an AI's ability to think abstractly, to reason, not just to recognize patterns it's already seen a million times in its training data. In other words, it's designed to be a pure, unfiltered test of intelligence.
And this quote from ARC's creator Francois Chalet gets to the heart of what makes it so tough. No outside knowledge. That's the golden rule. The AI can't just go search the internet for the answer, or rely on knowing what a car or a house looks like. Nope. It has to solve the puzzle using pure logic, with only the information right there in front of it, just like you did.
So, faced with this seemingly impossible puzzle, researchers all over the world started to form these different schools of thought on how to crack it. And this quest for a solution, well, it led to some really fascinating and very different strategies.
So how did people even try to solve this thing? Well, most of the attempts fell into one of three main camps. You can think of the first group as the toolmakers. They basically built a big digital toolbox full of simple actions. Flip, rotate, copy, fill, and then just tried to combine them in millions of ways to brute force a solution. The second group, you could call them the translators. They used large language models to look at the puzzle and actually write a computer program to solve it. And then the third group were the direct learners, who tried to build this giant brain, a neural network, that could just look at the input and like magic predict the output.
Here's a peek at that translator approach in action. The AI is literally being asked to act like a programmer. First, describe the puzzle's logic in plain English, then break it down into steps, and finally, write the actual code to execute it. It's a really powerful idea, but you can see the weakness, right? If the puzzle gets too abstract or weird, the AI struggles to find the right words and the whole process just breaks down.
Okay, so meanwhile, over in that neural network camp, this really clever technique started to pop up. It's called test time training. The idea is, you train a huge model on thousands of puzzles beforehand, that's normal, but then for the actual test, you do this last-minute, super-fast training session using only the examples from that one specific problem you're trying to solve. It basically lets the AI specialize on the fly, giving it a much, much better shot.
For years, all these different methods just kept hitting a wall, with top scores stuck around 30%. It felt like nobody was getting any closer. But in the 2024 competition, one team made this massive leap forward. And their breakthrough wasn't just some clever new algorithm, it was a totally profound new idea. They taught the AI how to reflect on its own answers.
And this insight is what changed everything. See, most of the previous attempts were just obsessed with finding a single correct answer. The winning team realized the real challenge isn't just finding an answer, it's figuring out which of your many possible answers is the right one. They had to teach the AI how to check its own work.
And they did it with this elegant three-step process. First, instead of looking for just one answer, they had the AI explore a bunch of different paths to generate lots and lots of possible solutions. Then, and this is the magic trick, they took the original puzzle and created 16 remixed versions of it, rotated, flipped on its side, mirrored, the whole deal. And finally, the cross-examination. They made the AI score every single one of its own potential answers against all 16 versions of the puzzle.
And this is the beautiful, simple insight at the heart of it all. A wrong answer might look convincing at first, but if you flip the puzzle upside down, the logic just falls apart, and the AI knows it's wrong. But the correct solution? It's robust. It looks right from every single angle. It consistently scores high no matter how you twist or turn the puzzle. It's the one answer that holds up under pressure.
And the result of all this? 56.5%. Now, I know what you might be thinking. That's not a perfect A+. But in this competition, that number was like an earthquake. It nearly doubled the previous record and finally shattered a problem that had stumped the entire field for years. It was a massive leap.
So a huge breakthrough for sure. But what does it really mean for the future of AI? Well, it's really helped clarify the path forward.
and it highlights two major directions for building smarter, more powerful reasoning systems.
You can think of these two paths as the better ingredients approach versus the smarter chef approach. Better ingredients is all about making better training data, smarter problems for the AI to learn from in the first place. But the smarter chef approach, which is exactly what this winning solution did, is all about creating models that are better at adapting in the moment, using feedback and self-evaluation to think their way through a totally new problem. And as we just saw, in 2024, the smarter chef definitely won.
Ultimately, this whole thing isn't really about colorful grid puzzles. It's a blueprint for a totally new kind of AI, one that can reason abstractly, check its own work, and find solutions that are genuinely robust and reliable. We've managed to teach an AI how to solve a puzzle that was basically designed as a stand-in for human intelligence. So the only real question left is, what real-world problems are we going to ask it to solve next?